for the slope-intercept form, it's just normal. It's just this. And for point slope form, we have that m is the slope and x1, y1 is the point. And for standard form, it's just ax plus by plus equals c, where a, b, and c are all integers, and a is positive. And we also have that if two lines are parallel, then that means that they have no solution in common. And if two lines are perpendicular, then their slope multiplied by each other is -1. If two lines if a line is horizontal, their slope is 1 or 0. Yeah, 0. And if vertical lines have undefined slope. So for homework review, I would have two of you. I would like to have one of you guys do it. So if someone wants to share their solution that they did in homework, go ahead. Anyone want to share the solution about this homework review? Okay, go ahead, Nathan.
Never mind.
Huh?
Never mind.
Okay, so if no other people wants to share the solution, then I guess I'll just do it. Okay, so integral coordinates x and y are selected such that this holds. How many distinct values of m are there possible if the graph of the equation passes through this point right here? Okay, so for this one, we can just make a grid. Okay. Okay, so we have 1 line, 2 line, 3 line, 4 lines, 5 lines, and we also need that the lines are either this line right here or above. So there's this 1 line, 2 line, 3 line, 4 line, 5 line, and 6 line. And then we also have that this passes through this point. So it's like this. And we have a 7th line, 8th line, and then 9th line, 10th line, and finally 11th line. So we have 11 lines, but for this line right here, this one, this M is undefined because it's vertical. So we have to minus this one, so it's 10 as the answer. Questions? No questions, I'll move on. If anybody wants to share the solution, then go ahead. Raise your hand if you want to share your solution to this problem. If no one wants to share, then I'll just go ahead. So, for this problem, write a standard form sorry. Write a standard form of the equation which has the x and y intercept of the equation of this switched. So it means that the x-intercept of the equation we want is the y-intercept of this. And similarly, the y-intercept of the equation we want is the x-intercept of this. So we have that the slope of the original line is 4/9 because this is in point slope form and this is the slope. And so since we swapped the x and y intercepts, the slope would be the reciprocal of the previous slope. So it would be 9/4. And with slope 9/4, for this equation right here, we have that the y-intercept is equal to -8, and the x-intercept, if we convert this into standard form, we would have 4x minus 9y equals 72. So the x-intercept would be equal to 72/4, which is 18. So for the new one, we have that the x-intercept is -8 and the y-intercept is 18. So since we want it in standard form, we have that 9x minus 4y equals something. And we want to calculate that something. We can use the x-intercept, which is -8. The x-intercept is just this number over 9. So this number would be -8 times 9, which is -72. So we have that this is our answer. Questions?
Where'd you get -72?
Oh, because that, look right here. So this is the ax plus by equals c. So we still don't know this one right here yet. but we want to calculate it. And since the x-intercept is just c over a, and since a knows 9, so this would be c over 9, which is 8. So c would equal negative 72. Mason, you get it? Okay. Any other questions? No one has any other questions, then I'll move on.
Wait. If y is 18 and x is negative 8, 9 times negative 8, negative 72, right? And
Yeah.
4 times 18 is 72.
No, it's negative 4 times 18.
Oh,
Because
my
we
bad.
have a negative sign right here. Okay, so I'll move on to the next content. So okay. So for this problem, I'll give you guys maybe 2 minutes to solve it. Okay, so for this problem, does anyone want to share their solutions?
I got 81.
Mason, if you want to go over, you can.
So since 3 to the power of 4 times 3 to the power of 9 times 3 to the power of 15 is just 3/4 multiplied together, multiplied by 3, 9 threes, multiplied by 15 threes, which makes a total of 28 threes, which is 3 to the power of 28. So the numerator is 3 to the power of 28. And then the denominator is 7 threes multiplied together, 11 threes times multiplied by 11 threes multiplied by 6 threes, which makes a total of 24 threes. And so 3 to the power of 28 over 3 to the power of 24 is just 3 to the power of 4, because the 24 threes cancel with 24 of the threes that are multiplied. So that just leaves 4 threes, which 3 to the power of 4 makes 81.
Lewis, I think you're muted.
I know. Okay, good job. Wait a minute, guys.
Wait, can I switch devices real quick?
Sure. And you don't have to ask me these questions.
Can you let me in?
Okay, so over here we have a few exponent rules, but it's only if A is not equal to 0 and B is not equal to 0. Okay, so the product rule, we have that A to the x times A to the y equals A to the x plus y. And the quotient rule is if A to the x over A to the y is equal to A to the x minus y. The power rule is A to the x to the y is A to the xy. And the power of a product rule is just AB to the x equals A to the x times B to the x. The power of a fraction rule is just A over B to the x is just A to the x over B to the x. And the zero exponent is just that A to the 0 equals 1. And the negative exponent is A to the negative x, where x is a positive integer. A to the negative x equals A to the x 1 over A to the x. And the fractional exponent is A to the x over y equals A to the x, the y square root of a to the x. And so these right here is just the power rule, which is the one right here. And one of the common mistakes is that 7 to the 4th times 7 to the 2 is 7 to the 6, and not 42 to the 6, where you multiply the bases and you add the exponents, nor if you multiply the exponents. So these are not true. And yeah, questions about these? Question about these? No questions, then I'll just move on. So, exponents and radicals, negative and zero exponents. So, we have that a to the 0 equals 1 because 1 equals a to the x plus a over a to the x, which is a to the x minus x, which is just a to the 0. So, unless when a equals 0, when the case is undefined. And a to the negative x is just 1 over a to the x, because 1 over a to the x is just a to the 0 over a to the x, which is just a to the negative x. Unless if a equals 0, which this case is undefined. Okay, so I'll give you guys 2 minutes to solve this problem right here.
Does it say to the power of x or multiplied by x?
Do you mean? And where? Where do you mean?
It says 3. Is it? It's 3.
Oh, it's 3 to the power of x plus 4 to the power of x.
Okay.
Okay, so does anybody want to share their solution for this problem? Go ahead, Jason.
Me? So,
Yeah, sure, if you want.
so x equals 0 because anything to the power of 0 is 1 except for 0. So 3 to the power of 0 is 1 plus 4 to the power of 0 is 1. So 1 plus 1 equals 2.
Okay, good job. But it's not that really rigorous because like how did you know that it was 0? Did you use trial and error or did you use something else?
Mainly knowing the anything to the power of 0 except for 0 is 1.
Okay, so but I have another solution that's more rigorous, but it might require some stuff that you guys might have haven't learned before. So first, we have that 3 to the x equals, say, y. So we have that. Suppose that's y. Therefore, we have that log base 3 of y equals x. And we have that log base 3 of z equals x if 4 to the x equals z. Sorry, this is 4. For this, we can, one of the ways is to use trial and error. So, like, right here, if we can, like, try x equal 1, so log 3 equals 1, because 3 to the power of 1 equals 3. And we have, if we also have x equal 1, so it's a log 4 equals 1. And we have that 3 plus 4 equals 7, which is obviously not true because we want it to be equal to 2. So this is not true. We can't use x equals 1. Okay, we can try x equals 0. So y would equal 0 because 3 to the power of 0, y would equal 1. And then right here, x equals 0, z would also equal 1. So 1 plus 1 equals 2, which is 2. So we have that x equals 0. Okay. So I'll move on. And
Could you move up a little?
so if we're expanding an exponent, we just have 2 to the third power 2 to the 5 will just equal 2 to 3 multiplied 5 times, which is just 2 to 3 times 5, which is just 2 to 15. And this is also general, because suppose the 2 is just an a, and we have a to the x to the y. So we just have a to the x times a to the x times a to the x times dot 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 times a to the x, where a to the x is multiplied y times. So this would just be a to the x times y, which is just a to the xy, which is the one right here. Okay, so I'll give you a few minutes to solve this problem. Okay, anyone wanna share the solution? Anyone wanna share the solution? No one does, then I'll just go over it myself. So we have this expression 2x to the fourth to negative fourth to the 1 over fourth power. So this is just equal to 2 to the negative fourth times x to the negative first power to the 1/4 power. So this would just be 2 to the negative 1 power times x to the negative this is negative 16. So x to the negative fourth power, which is just 2x to the fourth, 1 over 2x to the fourth. Or it's just 2 just wait. No, yeah. So it's 2x to the fourth to negative first power. Questions? No questions, and I'll move on. So for this fractional exponents, we just have that x to the x over y, a to the x over y would just be a to the x to the y root. So yeah, I will give you guys a few minutes to try and solve this problem. Okay, does anyone want to share their solution? Go ahead, Nathan. I think you're muted, Nathan.
So because 8 squared is 64 and 64 cube root is 4, 8 to the power of 2 over 3 is 4. And then when you multiply by 25 to the power of 1 is 25. And then 25 square root is 5. And then 4 multiplied by 5 is 20.
Good job. So, I'll just move on.
Can you move up?
Okay, so usually on a contest, you will need to simplify the roots by taking out the perfect squares inside. So we can use the fact that root A times root B equals root AB. So root 48 will just equal root 16 times root 3, which is 4 root 3. And we also have that root of x squared equals x. Root x squared equals x, but this rule is only there if x is non-negative, which means x is not a negative number. And we have root x times root y equals root xy. And we have that root of x over y equals root of x over root of y. So I will give you guys a few minutes to solve this problem.
Can you move that black thing that's covering rules for square roots thing? Lewis.
Okay, does anyone want to share the solution for this problem? These two problems?
Mm,
Go ahead, Finley.
sure.
So square root 300 equals to square root 100 times 3, which is equal to 10 times square root 3. And square root 2 times square root 8 is equal to square root 16, which is 4.
What do you say, Finley?
I said like square root 300 equals to square root 100 times 3, which is equal to 10 times square root 3. And for the second one, square root 2 times square root 8 equals to square root 16, which is 4.
Is it just me, or can everyone not hear Finley? Because I can't hear you.
It's just you.
Yeah, it's just you.
Try changing your speaker.
Or maybe it's just me, so I'll just go over this problem myself and I'll end class. So for root 300, we have that the prime factorization of 300 is just this. It takes out a 2, 150. Another 2, if we take out another 2, gives us 75. If we take a 3, gives us 25. If we take a 5, it takes out 5. And since 5 is prime, we can't take out anything from it. So it would just be 2 squared, square root of 2 squared, times square root of 3, times square root of 5 squared, which is just 10 root 3. Because it's just 2 times 5 times root 3, which is just 10 root 3. So this is the answer to our first problem. For the second problem, it says root 2 times root 8, which is equal to root 2 times 2 root 2, which is just 2 times root 2 squared. And using this rule right here, we have that this is 2 times 2, which is 4. And that's our answer. So I'll end class right now, so
Wait,
you guys can leave now.
can you move that?
Thank you.
That gray thing that's blocking
Thank
rules
you,
for square
Lewis.
roots?
Bye.
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 Bye. Thank you.